Hey everybody, this is Mr. McKee with Net 226. Today I'm going to be going over Packet Tracer 2.7.1, which is Single Area OSPF version 2 configuration. Alright, I just opened up this Packet Tracer, so the workspace is still converging. See the little orange and red triangles, a little orange now. So I'm going to hit the fast forward time button. Alright. Everything's up except for this interface going out to the cloud, but that's probably not turned on yet, so we won't worry about that right now. But just looking at this, alright, we have 3 local area networks connected to the headquarters network and 3 routers, P2P-1, -2, and -3. Notice the subnet masks. You got a 24, 24, and a 28. Alright, you have \30s for all these networks, router to router, and then you have a router to router connection between headquarters and data services, and then data services is BC1 router that goes down to a switch, and then over to BC2 router and BC3 router, and then they're both connected to, or they're both each connected to their own local area networks. Alright, so here's the addressing table. Looks pretty straightforward, I believe. P2P1, alright, 10.0.0.0 network, zero network, 8 network, and 12 network. Okay, so those look fine. PC2 or P2P2 has 4 interfaces. And for some reason, for a while, I couldn't mouse over anything and see the interfaces. It's working now, but I had to restart Packet Tracer a couple times. So this shows us our interfaces. So that looks fine. P2P3. Alright, .6.10, 192.168, 3.1. Alright, BC over here has one connection back to headquarters, one over to data services. Alright, that's the one going out to the internet right there, 64 dot network. Okay. Then you have internet server out here, PC1, laptop 1, work group server, and 2 PCs. Alright. The biggest difference between these, you have point-to-point, and they named them P2P, so point-to-point routers over here for headquarters network, and then a broadcast multi-access network for data services, because it's going through 3 routers going through the same switch. Alright, so let's take a look. Implement single area OSPF version 2 in both point-to-point and broadcast multi-access networks. The background is you are helping a network engineer test an OSPF setup by building a network in the lab where you work. You have interconnected the devices and configured the interfaces and have connectivity within the local LANs. Alright, your job is to complete the OSPF configuration according to the requirements left by the engineer. Use the information provided and the list of requirements to configure the test network. When the task has been fully completed, all hosts should be able to ping the internet server. Alright, so we're going to configure the network to meet requirements, and pretty much this is all it gave us. Just requirements. Alright, so we got to kind of like do this from scratch, more or less, even though there's some stuff configured. And if you notice, I haven't even touched anything, but as soon as everything converged, you got 25% completion rate. So don't think that's odd. Alright, and probably what I want to do, let's think about this. Alright, so what I think I'm going to do is, let's go ahead and get started, but the requirements are use process ID 10 for OSPF activations in our routers. All right, so we're going to use OSPF 10. This is going to be area 0. It says right there, OSPF area 0. All right, so activate OSPF using network statements and inverse masks or wildcard masks on the routers in the headquarters network. So the first thing we're going to do is do these 3 routers. All right. And I can probably do these in my head, but I'm going to just go ahead and go through them. All right, so let me do this. Backslash 24, and then I want to click this, drag it all the way to 32. All right, so just assume we're going to have a backslash 24 through 32 subnet. So we have 24, 28, and 30. All right, so we just need to figure that out real quick. That'll be a dot 0, and I'm going to do this format as text. If not, it's going to take my dot 0 off. All right, text. All right, now dot 0 dot 2 or 192 dot 128 whoops, I'm doing that backwards. 128, half of 256 is 128, half of 128 64, so 128 plus 64, 192, and then so on. 128, 192, 224, 240, 248, 252, 254, 255. All right. Let me insert. All right. So that's our CIDR. Subnet and wildcard. So the wildcard is going to be the inverse. So wildcard equals 255. If I can type 255 minus the subnet. All right, so let's just remember that. All right, so 255 minus 0 is 255. And I'm going to format these as text. Though I could have format painted. Let's do format painter. Those. All right, dot 255. All right, so I'm purposely trying to make this as unautomated as possible so I can think about, we have to think about how to do the subnets in wildcard mask, but what I'm going to do is, to make it a little bit easier, let's see, let me format this back to a number, no decimal places. All right, so everybody knows this is going to be dot something, so it'll be dot 0. So 128, 192, 224, 240, 248, 252, 254, 255. All right, so we're going to make the wildcard is going to be equal to, let's see if I can do this, I haven't done this in a while, 255 minus this. Maybe it's without the parentheses. Nope. Oh, you know what? I know what the problem is. Let's format this as a number. And that's going to look a lot better. Minus that equals, all right. that I have that all straight. All right, there's our wildcard masks, automated. All right, cool. And the big ones we're looking at is we need to make sure we know what a 24 is. So that's going to be a wildcard mask of 0.0.0.255 because a wildcard is the inverse of 255.255.255.0, or just take 255 minus whatever numbers in the subnet, and that'll give you the wildcard, and then so on down here. I know these numbers look like they're one off, but the reason they're one off because you got to remember 0 is in binary, 0 is the first number. So like here, if you did a wildcard mask 0.0.0.3, that means .0, 1, 2, and 3 are your 4 usable IP addresses, all right, in that subnet. So that's perfect for router-to-router connections because you got two interfaces, the network address right there, and then a broadcast. In that case, it would be the broadcast would be 3. All right, and then so on. So we've got to know 24, we've got to know 28, which is right there, and 30 is right there. So that'll be 28 will be 0.0.0.15. All right. So we got that straight. All right, so activate OSPF using network statements and inverse masks on the routers and headquarters network. All right, and just start off in numerical order. I'm going to start off with P2P1, and I guess it's the easiest to look up here. All right, we're going by the networks on this one, but just go by the, I guess it shows the networks right here too. The 0, 4, and 8 network. All right, so let's go to 1. You can see how there's no OSPF messages in there yet. So let's go to enable. Figure T. All right. So we want to process ID 10. So we're going to do router. Oh, you know what? Yep, router OSPF 10. So that's our process ID 10. All right, and then we're going to do our 3 networks rather. So network is going to be 10.0.0.0. All right, the 10 network, and then we're going to do a wildcard mask. They call it an inverse mask, but since it's a 30, it would be right here, 0.0.0.3. All right, and that's the inverse of 255.255.255.252. Because 255 minus 252 is 3, so that's right. All right, let's see. Area is going to be 0. We're going to put on the area. All right, and now the net. And we can use the up arrow to keep our history and update that. All right, see how we're starting to get OSPF messages. All right, so our next network is going to be the .8, and that's also a 30, so we'll leave the 0.0.0.3 there. What's the problem? What do we do? Network. .0.0.0.8.0.0.0.3. Must have hit back or something. Something went weird. All right, let's try it. 12 network. right, so we've entered the .0 network, .8, and .12. All right, that's the first one. All right, now let's do P2P2. All right, so the router is 10 again, network. So this is going to have 4 networks. So let's do the 10.0.0 first. 0 with a 0.0.0.3. It's a /30 area 0. All right, a .4. All right, a dot. Let's make this a 192.168.1.0, and the inverse of a 24 is 0.0.0. Here. Wildcard is 255, so 255. All right, then a go up arrow, and then whoops. All right, there we go back. All right, so we got a all right, so that should be good for the network. And actually, let's exit to show run. Just check our networks. And I didn't even enter that. You can enter that to make it, the interfaces not send OSPF messages, but that must have already been entered. All right, and I didn't enter this auto cost either. All right, so we got that network, this network, that network, and that network. All right. Let's go to P2P3. All right. It's going to have 3 networks. So router OSPF10. All right. So let's do network 10.0.0.4 with a wildcard of 0.0.0.3. Area 0, then up arrow, change it out with a .8 network, and then 192.168.3.0. Now this is a /28, so that's probably going to be a 0.0.0.28 is 15. All right, let's exit out of that, do show run. And see how this is showing a passive, that was already entered, that passive interface gigabit 000, but we have 192.168.3.0, which is that gigabit interface, with a .255 wildcard network 10.0.0.0.0.3, network 10.0.0.8. All right, so those look good right there. All right, so that should be good for there. All right, activate OSPF by configuring the interfaces on the network devices in the data services network. where required. So that one's going to be required. This one, this one, this one, this one. Okay. So now we're just going to put the interfaces in for these, and then just do IP OSPF area 0. All right, so let's do this. All right, let's start with BC1. So this interface probably won't be needed. So we won't do serial 0, 1, 1. We'll do, come on, serial 0, 1, 0, and gigabit. So not this outside one. All right, the interface 0, IP OSPF area 0, IP OSPF 10. Oh, I'm going to put my process ID in there. All right, see if I can go to interface. We're going to skip this one. We're going to skip serial 0, 1, 0, 0, 1, 1. All right, so interface gigabit 0, 0, 0. Yep. IP OSPF 10 area 0. All right, so like that. Let's go down to BC2. Do the same thing. And I'm going to do both of these interfaces. It hadn't told me not to yet. It says activate OSPF by configuring the interface on the network devices in the data service network where required. So I'm just going to go ahead and do both of these. KT interface gigabit 0, 0, 0, IP OSPF 10 area 0, and then interface gigabit 0, 0, 1. Whoops, interface gigabit 0, 0, 1. IP OSPF 10 area 0. Alright, so that one should be good. Let's do BC3. Alright, start with gigabit 0, 0, 0. Okay. Interface gigabit 0, 0, 0. IP OSPF 10 area 0. A lot of times I forget the process ID, so it'll error out. Alright, so next interface would be gigabit 0, 0, 1, IP OSPF 10 area 0. Alright, so that should be good. Now let's go back and check. Alright, so gigabit 0, 0, 0, there you go. IP OSPF 10 area 0, and then serial 0, 1, 0. IP OSPF 10 area 0. This outside interface does not have it. We can put it in there if it, well, it's not going to want it, but if it wanted it, we can put it in there. Alright, so let's go down here, do the same thing. Alright. Let's see if it'll work from there. Do show run. Oh yeah, it goes straight from there. Alright. Alright, so gigabit 0, 0, 0 does have IP OSPF 10 area 0 and 0, 0, 1 also right there. Alright, so that's good. And then 3. to show. I'm trying to remember when I took the certification exam, I didn't go from global config and try to do like show commands from there. I don't know if I was able to do that, but that's one of those things that might speed up the process. All right, so gigabit 000 has OSPF running and gigabit 001. All right, so all that looks good. All right, let's go down here. All right, so we've done that. Configure router IDs on the multi-access network routers as follows. All right, so let's set the router IDs. All right. And usually they have these numbered as the same as the name of the router. In this case, they did. It's kind of like they did it backwards. So let's do Control C. Router OSPF10. All right, it like that for router 1. Or I'm sorry, BC1, BC2. Control C, exit, router. OSPF 10. Router ID 5.5.5.5. And then 3 is going to be Control C, exit, router OSPF 10, router ID, whoops, router ID. If you get the log messages while you're typing, just hit tab. All right, router ID is going to be 4.4.4.4. All right, so like that. Let's continue on. All right, configure OSPF so that the routing updates are not sent to networks where they are not required. Okay. So we didn't even do them here. We could do them on this interface, this interface, this interface. And really these two interfaces also. So if you see gigabit 000 and 001 already have set on that one. All right, so P2P3, this would be gigabit 000. That needs a command right there. Whoops. All right, I had to answer my phone. All right, let's see. P2P3, which this interface is gigabit 000. Where is it? 000. Oh, it's right there. 000 passive interface gigabit. So it's already set. All right, so let's look over here. I would say passive interface that way. So the one going out to the internet on BC1 is that one, 0011. So I can make that a passive interface. Is that right? Serial, oh, 0, where's that? BC1, 011. All right, that takes care of that one. And let's look at this one. Because that would be that interface right there. Gigabit 000. All right, let's get it back. All right, passive interface gigabit 00. It's going that way. 192.168.4.4.1 0.0.0. All right, that looks good. Let's go to PC3. Now the passive interface should be 0.0.0 also. All right, we're already at the config line for the router. So let's do passive interface gigabit 0.0.0. All right, so that takes care of that one. All right, so that should be set right. Configure router BC1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. All right, so if we're going to configure the BC1 with the highest OSPF interface priority so that it will always be designated router of the multi-access network, so that'll be this interface. All right, and that is interface gigabit 0.0.0. All right. Priority, if you do question mark 0 to 255. Higher numbers, the higher priority. Highest priority would be 255. All right. So let's see. Configure the default route. Configure the default route to the ISP cloud using the exit interface command argument. Okay. All right, so that interface is going to be 0011. All right. 001. All right. And that's BC1. All right. So configure the default route to the ISP cloud using the exit interface. All right. I can do that in the interface. That's not gonna work. Let's do here, big T. 0, 1, 1. All right, default route without gateway. All right, it's point-to-point interface, so it doesn't matter. That's fine. All right, automatically distribute the default route to all routers in the network. All right, so let's go BC1. All right. Is it default? Default information. I think it's information. Question mark. All right, Control C, default, question mark, interface. Ooh, I wonder if I need to do this. IP OSPF10, IP OSPF10. Trying to remember. All right, I don't know if I'm losing my mind. OSPF. Router for OSPF10. 10. And if you guys would, what I'm looking at right now is right here. We got to set our default information originate, so it gives us the default route. All right. And then you'll see the root source in R1, R3, O. So it's assigned it. So default information originate. All right, I want to configure OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. Okay, so what we need to do, all right, so we need to see what's already been configured. I believe, let's see. Show run. See, this is already being configured with autocalls reference bandwidth 1000, which would be this right here. Gigabit Ethernet cost will be 10. Fast Ethernet cost will be 100. Okay. And what I could do right here, I copy that. All right. P2P2 is already done. P2P3, I believe, is already done. Yeah, it's right there. So we go up here. All right, so this has not been done. P2P-1. So enable router OSPF10, router OSPF. Oh, yep. Okay. OSPF router OSPF10. All right, now let's paste this in there. Reference bandwidth has changed, that's fine. All right, let's go up here. All right, let's do config T. Router is PF10. Paste this in there. let's check this. Alright, let's go enable, show run. Alright, T router OSPF10. Paste this in there. Alright. And if you guys want to read more on that, I haven't used that much, so I actually looked it up again. I'm looking on page 2.4.1, which is just cost metrics, and we're using a gigabit. Alright, so auto cost reference bandwidth 1000 in megabits, so gigabit. Alright. Alright, so let's get out of there. Alright, so configure the OSPF cost of P2P-1 interface serial 011 to 50. Alright, so P2P1. Exit out of that. Interface serial 011. OSPF almost 50. Yep. All right. And then configure the hello and dead timer values on the interfaces that are connecting, that connect P2P-1 and BC1 to be twice the default values. That connect P2P-1, which is that one. So that serial interface to that serial interface, both of those, the default values would be the hello would be 40 and the hello would be 10. Dead would be 40. We're gonna make those 20 and 80. Interface serial 0 to 0. OSPF hello interval to 20. Dead interval to 80. Okay, yeah, that's right. And I'm going to keep that. Okay, serial 010. Alright, let's go to interface 0010. Okay, IP OSPF hello interval to 20 and IP OSPF dead interval to 80. Alright, wow. That was a good bit of configuration. Alright, I'm getting hello messages, neighbor messages. Everything should be good to go. Alright, so what you need to submit for this is check results, make sure it says congratulations whoever you are, you completed the activity. If you've missed anything, probably the most confusing thing was some of this stuff's already configured, like the auto cost was configured for a couple of different routers, and things like that. So screenshot of that, .pka file, and there wasn't any questions, so you don't have to submit a Word document. All right, but this one definitely is probably the longest one out of this week's packet tracers. All right, so, and this is the last one for this week too, so if you're done with this, you should be good to go other than the first test. All right, thanks for watching.